Good morning, good afternoon, boys and girls. This is Module 3, Topic 4, Lesson 3, Texas Tea and Temperature. In this lesson, we will be using multiple representations to analyze and interpret problem situations. And those multiple representations are tables, graphs, and equations to represent and solve word problems by reasoning about their quantities. Alrighty, let's get started. Today we are starting with activity 3.1. In this activity, we're going to be creating those multiple representations, the equation, the graph, and the table by starting first with the description of the problem. At this time, I'm not going to read it for you, but I want you to read it out loud, either as a class or on your own. Remember, as you read, annotate the information that's being given. Pause here. Now, while reading, you should have annotated to understand what this description is talking about. To bring this picture to life, I'm going to show you really quickly what a 2,500 gallon oil tank looks like. It looks like this, okay? So we can't copy and paste this picture onto our workbook, but we can draw it. So that's what we're going to do here. So really quickly, I sketched up a giant cylinder, and I also color coded it for you to help you better understand what's happening. But the green represents how much it currently has, which is the 2,500 gallons of oil. The blue represents the total capacity, so the max amount of oil that this tank can hold is 3,000 gallons. And the rate that it's being emptied, which tells us in the description, is 25 gallons per minute. And think about it, if it's being emptied, are we adding or are we subtracting? Right, we are subtracting. So it's going down 25 or negative 25 per minute. All right, so let's get started. Question number 1 says, how many gallons are currently in the tank? Number 2, it says, how fast is the tank being emptied? Question 3, it says, what are the two quantities that are changing? Define variables for the quantities and identify which is the independent variable and the dependent variable. And then number 4, it says, what is the unit rate of change in this situation? And lastly, number 5 on this page, write an equation that relates the two quantities. So the reason I read all questions 1 through 5 is because I do want you to answer these on your own first. I believe in the last activity, we were able to go from description to identifying the variables to writing an equation, and that's exactly what you're doing in these 5 questions. Now, before you pause and work on 1 through 5, I am going to give you a word bank for question number 3. So here's your word bank. Out of these 4 options, you're going to use 2 of those to answer. Number 3, what are the 2 quantities that are changing? And then you're going to define the variables, meaning which one is dependent on the other. If it's dependent on the other, then it is the dependent variable. If it is not dependent on the other, then it is the independent variable. Now at this time, I'm going to attempt to show my whole page. There we go. And you're going to take about 5 minutes and no more, 5 minutes to answer questions 1, 2, 3, 4, and 5. 5 minutes on the clock. Go ahead and pause here. Alrighty, now that you've had 5 minutes to answer these questions, we are going to compare answers. Question number 1, how many gallons are currently in the tank? That's an easy one. There are 2,500 gallons in the tank. Now, a best practice is to put your answers in complete sentences, but if you did not this time, that is okay. Let's keep moving. Question number 2, how fast is the tank being emptied? Well, that was also plainly given to us in our description, but the tank is being emptied at a rate of 25 gallons per minute. We literally highlighted that in orange. Question number 3. What are the two quantities that are changing? And then which is the independent and dependent? The quantities that are changing are, for this, I put the quantities that are changing are the minutes draining. Sorry, there should be an S there, meaning the time, right? And the amount of oil in gallons or the gallons left in tank are also or is also continuously changing. The variables and the independent and dependent variables that I identified were M for minutes and G for the amount in gallons. And that just helps me, I know when I'm calculating in my equation, to understand what exactly it means. You could use different variables, but just be sure that if you're using a T for time, that you're not getting it confused with an addition sign. All right, and number 4, what is the unit rate of change in this situation? Well, that would be negative 25 gallons per minute because it's changing at a negative rate at 25 gallons per minute. It's being emptied, remember? So it's negative. And then number 5, write an equation that relates the two quantities. Well, remember when building your equation, always think about where we're starting. So our oil tank is starting at 2,500 gallons. And we know what is happening here. It's being emptied. So subtract 25 gallons per minute. So 25 each minute, right? And I know that's going to then equal the amount I have left in my tank in gallons. So I've got 2,500 minus 25 times M is equal to G. Of course, this can also be written as G is equal to negative 25 per minute plus 2,500 because that's our starting point. Go ahead and take a couple seconds and get that down. And then we will be moving on to question number 6. Alrighty, question 6. It says, how many gallons will be in the tank after a quarter of an hour, B, 5.5 minutes, and C, an hour and a half? Now, to answer this question, you will need 2 things. First thing you will need is your equation. So I'm going to rewrite that on this page so that you can all see it. But our total gallons will equal 2,500 minus 25 M per minute. And the second thing you will need is to also know, well, what is, and I'm going to draw a clock to kind of help us represent time, but what is a quarter of an hour in minutes? What is 5.5 minutes in total minutes? Or what would that look like in an equation? And then what is an hour and a half in minutes? So I'm going to help you out a little here because I want you to be successful. So if we think about an entire hour, that is 60 minutes. We know that. But if I want to know what a quarter of an hour is, think about a quarter to a dollar. I know that's going to be 1/4 of an hour. So I'm going to split this into fourths. And now I'll be able to easily see, okay, what is 60 split into 4 equal sections? I can divide or I can reason. Well, 60 split in half, I know is 30. And 30 split in half is 15. So I know that 15, 15, 15, and 15 give me 1 full hour. So I know that the time that I'm going to use is 15 minutes in my equation for 6A. For 6B, it's already in minutes, so I don't have to change anything. I can just simply write 5.5. So how would you write that? You can write it in decimal form or fraction form, however you feel. Now 6C is an hour and a half. So again, using that clock, we need to think, Well, no, use green. What is a whole hour and then also an additional half an hour? Oops, that's the wrong tool. An additional half an hour in minutes. So you would add that up and then write that in minutes for 6C. All right, I've helped you out. I've given you a head start. Oh, wait, never mind. Hold on. One last thing. Just so there are no excuses as to what you need to do or I don't know where to start, I'm going to go ahead and give you the first equation to set up. So for 6A, using your equation, you should substitute in that 15 minutes for time. So you've got G is equal to 2,500 minus 25 times 15. All you're doing is solving that to figure out, well, what is G equal to? That's going to tell you how many gallons will be left in the tank after 15 minutes. Alrighty, at this time, take about 5 minutes, set a timer for 5 minutes, work on 6A, B, and C. If you don't finish them all, that is okay. In 5 minutes, come back so we can compare answers. Pause here. Alrighty, now that you've had time to work, let's compare our answers. Alrighty, for 6A, notice I solved step by step. So I first solved 25 times 15 and then got 375. And then my second step, I subtracted 2,500 minus 375 and got 2,125 gallons. And I boxed it in green. For 6B, I did the same thing. I took it step by step. I substituted in 5.5 minutes for where our minutes were represented in our equation. And then I solved 25 times 5.5 is 137.5 or 5/10, 137 and a half. I subtracted that from 2,500 and got 2,362 and 5/10. And for 6C, 25 times 90 because an hour and a half, so 60 minutes plus 30 more minutes gives you 90 minutes total. That gave us 2,250. I subtracted that from 2,500 and got 250 total gallons. Now, if you don't have all of this down, it's okay. You don't have to copy the work, but do copy the answers because this is going to be used later to fill in our table, which we'll then use to create our graph. So if you need about 10 seconds, pause here. Alrighty, your 10 seconds are up. Let's move on to number 7. When will the tank be half full and when will it be empty? Now, for this problem, it is similar to what you just did. However, pay attention to the information they're giving you. This time, they're giving you the amount of oil that's left in the tank. So they're giving you the G. So think about half full. Well, I know, and I'm thinking back to the information that was given on the previous page. There were 3,000 total gallons that could fit in the tank. That was the capacity of the tank when it was full. Well, if it's half full, then it is half of that 3,000. Think about it real quick. What is half of 3,000? If you said 1,500 or 1,500, you're absolutely correct. So that's what we're going to be substituting into our equation. 1,500 is equal to 2,500 minus our rate, 25 times M. Now, instead of solving for G, this time we're solving for M. Now, I've given you a head start. I want you to, on your own, to now solve 7A, 7B. Think about what does it mean when it's empty? How many gallons are in the tank when it is empty? And then I also do want you to solve 8 and 9 as well. So how long ago did the tank contain 2,600 gallons? Oh wait, I don't want to use orange. I want to use green because that represents the amount of gallons in the tank. And then how long ago was the tank full? Remember, at full capacity, that was 3,000 gallons. It gave us that information. And being that it says how long ago, what does that tell you our answer is probably going to be? If you said negative, you're absolutely correct because we're talking about the time before the 2,500 gallons. Similar to the rock climbers, the time before we arrived, the time was negative. So this is similar. All right, I'm going to pause it here. And I want you to go ahead and continue with 7AB, question 8 and 9. Set a timer for about 5 minutes. Solve what you can, and then we will compare answers. Pause here. Now that you had time to work, let's compare answers. Let's start with question 7A. So the tank was half full, and we already discussed this at 1,500 gallons. So that's what we substituted into our equation. And then notice I took it step by step again. We're solving a two-step equation here. So I subtracted 2,500 from both sides to move that number to one side and get my variable by itself on the other. And so then I was left with negative 1,000 is equal to negative 25 times m. And again, to isolate that variable, I need to essentially undo what's happening to it. So the opposite of multiplying by negative 25 is dividing by negative 25. And what we do to one side, we have to do to the other. So negative 1,000 divided by negative 25 gave you positive 40 minutes for 7A. Then for 7B, my work is in brown to the left. I know that when it is empty, there are 0 gallons in the tank, so I substituted that in. And again, my steps were the same. I subtracted 2,500 from both sides, and then I divided negative 25 from both sides. I got m is equal to 100 minutes. Now, we want to keep it in minutes for our table and our graph. However, just know 100 minutes, if it were to ask us specifically about the time, would be an hour and 40 minutes because there are 60 minutes and then 40 additional minutes left over. For 8, it says, how long ago did the tank contain 2,600 gallons? Now, this, I got a little lazy. I didn't color code anything, but the steps, again, are the same. Okay? Subtract 2,500 from both sides. Then you got 100 is equal to negative 25m, and then divide negative 25 on both sides. You should have gotten negative 4 is equal to m, which means, well, the tank was 2,600 gallons 4 minutes ago. And then number 9, how long ago was it full? We know it is full at capacity, which was 3,000. And so then again, our steps are the same. Negative 2,500, negative 2,500. Sorry, subtract 2,500 from both sides and then divide both sides by negative 25. You should have gotten negative 20, which again means the tank was full how many minutes ago? 20 minutes ago. All right. If you need to take about 10 seconds to get just the answers down, you can copy the work for 1 or 2 to have that example to reference later. But the focus is the answer right now so that, and you should be copying while I'm talking, so that we can fill in our table and complete our graph. So take a couple more seconds to copy if needed. If you need to pause, take about 10 seconds, but I am moving on. Alrighty, question 10. Complete the table for this problem. So on this page, we are completing the table and also, let's keep scrolling, we are also completing 11, which essentially tells us to graph what we just put in the table. So I will help you get started by first filling in the quantities, units of measure, and a couple of those values that we got from our work in 6, 7, 8, and 9. Ready for the first part? Now, most times you won't be asked the quantities or I'll say that, the quantities. However, that is important to note, okay? The units of measure were minutes for time, and then the unit of measure for the gallons, or excuse me, the gallons not compared, the gallons represented the capacity left in the tank. And those variables we used were M and G. Now from the work we completed, okay, I paused to input the values, but here are the values that you already calculated for in questions 6 through 9. So you already know at 15 minutes how much or how many gallons of oil there were. At 5.5 minutes and 90 minutes, you've already calculated that. And then you calculated what was the time when the tank was half full, when it was empty, when it was at 2,600 gallons, and at full capacity, 3,000 gallons. All you're doing now is inputting those values from questions 6 through 9. Pause here, take 3 minutes to do that. 3 minutes max. This should not take you long at all. Pause here. Alrighty, your 3 minutes is up. These are the values that you already calculated that you should have put into your table. Alrighty, and now we're going to use these values to then graph our visual representation to create our graph. Now, there are a couple things that you're going to do here, and I'm going to highlight those for you so that nobody is confused. So first thing you're going to do is label the units of measure on each axis. So your X and Y axis. Again, think about your independent variable. I'll help you out. That's always X. And your dependent is your Y. Y is always dependent on X. So you're going to label those axes. Then you're going to plot all of the points. On each axis. Plot all the points from the table. And then graph the equation, which essentially is just connecting all of the points from your graph. And then that last note says make sure to label the units on the axis. That just means the time in minutes or the amount in gallons. And I'll even help you out to give you a head start. I'm going to choose one point to graph for you and to just give you an example of how you would graph. So I'm going to choose this point right here, 90 to 50. And to kind of give you some context, this would be written as 90, comma, 250. That is the point that we're looking for. So I'm going to look on my graph. I haven't labeled it yet because I want you to label it on your own, but I know 90 is going to be on my x-axis because that's my time. And so 90, it's counting. Each interval represents 10, so 10, 20, 30, 40. 90 would be somewhere between 80 and 100 on this line. And then 250 on my y-axis, let me arrow that. It would be somewhere there. And then on my y-axis, I see 300 is labeled. I know half of that is 150. 250 would be somewhere close to 300, but in between those values. So that would go somewhere here. Oh, sorry, that point's a little off. Somewhere there. Maybe a little higher, but you get the point. I'm also going to label one more for you. So think about where our tank is starting. We are starting at 2,500 gallons. So at 0 minutes, when nothing is being emptied, I know that 2,500 is my starting point. So I'm also going to label that on my graph, which is somewhere around here. At 0 minutes, I'm at 2,500. Now you can continue graphing your points. I'm going to pause here. Take about 3 to 4 minutes max to set up your graph and to plot your points. Pause here. Actually, I will pause it here just in case you don't have these values. And now pause here. Alrighty, time is up. Let's compare graphs. So your graph should look something like this, where your x-axis is labeled time in minutes, your y-axis is labeled capacity in gallons, and here you've got a line going down. Also notice all of those points you plotted should fall on that line or somewhere close to it because sometimes our points aren't exact, and that's okay. But look at it. We can clearly see the pattern. We can clearly see that all of these points would or should fall on this line. Also, we can clearly see our starting and our end point. So our starting point when our tank was full, we see that that was 20 minutes ago. And then 100 minutes later, our tank was empty. Now, I do want you to think about this question here. It says, how does your graph show that the tank is being emptied? How does it show that? What do you notice? I want you to take this time, talk with your neighbor about that. And this concludes this activity. Pat yourself on the back. I will see you all in the next video.